In this video, we start a new chapter called integration. So I'm going to introduce to you guys what the concept of integration is in this chapter, and we're going to use some application of integration. Section 4.1 is called anti-differentiation. So we're going to learn how to anti-differentiate here today, okay? But before we get into anti-differentiation, let's take a look at an example and try to understand what the heck we're going to be doing in this chapter. So first of all, suppose I give you a function called capital F of x, which is, I don't know, x cubed, for example. If I told you to find the derivative right now, you would say that the derivative is probably, if you remember, bring the 3 down, so you get 3, and then subtract 1 from the power. So instead of 3, you're going to have the power of 2. So going from the first function to the second function is called finding the derivative, or in other terms, it's called differentiation. And we're familiar with this process because we have been doing it for a while now. Now, what if I asked you to go the other way around? So what if I told you to start with the 3x squared and say, what function do you differentiate to get 3x squared? So if I told you to go the other way around, so if I told you I have 3x squared, what was the original thing? That is what we call anti-differentiation. Let's try another one. What if I told you capital F of x was x to the power of 4? Then what would the derivative be? The derivative would be called 4x to the power of 3. So going from the left side, from x4 to 4x cubed, that's what we call differentiation. However, going from 4x cubed back to x to the power 4 is what we're going to be calling anti-differentiation, okay? The symbol for differentiation is going to be a little apostrophe. That's the one we've been used to. The symbol for anti-differentiation is going to be this like S-looking shape. Okay, that's what we're going to be using to talk about anti-differentiation or anti-derivatives. Now, in this chapter, we like to give the derivative and the antiderivative different symbols so that things don't get confusing. So typically speaking, for these problems that we're about to do, instead of writing capital F apostrophe, what we're going to do is we're going to write little f for the derivative and capital F for the antiderivative. So if I told you what's the antiderivative of the little f of x, you're going to say it's the big F of x, which is x to the power of 4. Now, just some heads up. In these problems, the capital F of x, for example, in this last example, I said it was x to the power of 4. But I could have also added any random number like a 5 right here, or 5 over 3 or whatever. I could add any number I want because the derivative of a constant is going to be basically 0 on the other side. So it's not going to show up. And so since the number could have been there and I don't know what the number is, typically speaking for these problems, we're going to write a plus c, where c is just basically some real number. So in other terms, c is just a random number. We're just going to tag it on because if it was there, then who knows what it would have been, but its derivative would have been 0. So similar to the last problem where we said the derivative of x cubed is 3x squared, if I had a plus, for example, 7 right there, the derivative of 7 would have been 0. It would not have shown up in the second problem. So this is the reason why, since we don't know whether there was a number or not, we're going to put a plus c there just in case there was a number. And again, instead of writing capital F prime, what we're going to do is we're going to write little f of x. Okay. Now this notation is, up to debate. You can change it, whatever. Sometimes people mess with it. They write different symbols for different things, but that's the process of anti-differentiation. Now, if I told you, can you find the antiderivative of 3x squared? How would I write that down? How would I say what function has a derivative of 3x squared? The symbols that we're going to be using are going to be this little s, stretched out looking s, and then the dx at the end. So these two come together and they leave together. They both mean find the antiderivative. So you should be thinking to yourself when you see them, what function or what numbers or what variables do I take the derivative for to get 3x squared? And you should be thinking to yourself, it's x cubed plus c, where c is just some random real number. Let's try it again. If I said in the second example, what's the antiderivative or what's the inverse operation of 4x cubed? What function do you differentiate to get 4x cubed? You would say, well, x to the power of 4 plus c, where c is just some random number. Now, if you're worried that it's not possible for you to find these numbers, if you're worried that you can never ever guess the x cubed plus c or guess the x to the power 4 plus c, then don't worry. There's going to be a formula that we use for each one of those problems. We're going to use a formula that tells us what the antiderivative is for every situation. The formula that I'm speaking of is the formula that's written down in this table. Okay. There's also 4 other formulas, 3 other formulas, 4 in total on this table, but they're all used to find antiderivatives. So the first one basically tells us what to do if we saw an antiderivative of just a random number. So like, for example, what's the antiderivative of 2? According to the first formula, the antiderivative is 2x plus c, where c is just a random number. Why is that? That's because if I take the derivative of 2x, the answer will be 2. And the c, the derivative of that, will be 0. So, yep, that's the answer. The second formula basically says if you want the antiderivative of some letter with an exponent. So like, for example, if I ask you, what's the antiderivative of x squared? What function do you take the derivative for to get x squared? Well, the rule is add 1 to the exponent and divide by the same number. So I added 1 to the exponent 2, became 3, and I divide by exactly the same number, plus the c, where c is just a real number. This formula works as long as your exponent is not -1. So as long as the power that you're seeing is not -1, this formula works. And there's another 2 formulas we'll mention in a second when we get to them. Okay, so we're going to practice the formulas that we just learned with example 1. So the first one says 8, the antiderivative of 8 dx. So which one of the first or second formula works? Well, this is a pure number all by itself. Okay, so this is just a random number, which means that the antiderivative is going to be 8, the random number that you just had, and then multiply that guy by x. And then put plus c, where c is some real number. Okay, the answer to the problem is 8x plus c. And if you want to test it out, if you want to know whether you're doing it right or not, take the derivative of 8x plus c. If you get back the 8, then you know you did it right. The next one says 3x squared dx. So what's the antiderivative of 3x squared? That's going to be the second formula that we learned. It's 3x to the power of 2 plus 1 divided by the same thing, and plus c. So in other terms, this is going to be 3x cubed over 3 plus c, which is the same thing as x cubed plus c. And again, keep in mind that c is just some random real number. Again, how do you know that this is the right answer? Take its derivative. Do you get back 3x squared? The derivative says bring the power down, slide it over, take away 1, and yes, it turns out to be 3x squared. So that's how I know I'm doing it right. So now let's talk about the other 2 formulas. So the other 2 formulas will somehow come up with logarithms and exponentials. Those are functions that we learned in a different chapter. So the exponential one says if you want to integrate an exponential problem, you're going to get the same answer back, but with an extra number. So whatever number you have in front of the x is going to be the number that goes on the denominator. So normally you have to identify what the number is and just put 1 over that number. And if you see 1 over x and you want the antiderivative, the answer is always going to be ln of absolute value of x plus c. So let's practice those problems, those formulas down here. So this one says antiderivative of e to the power of x dx. So what's the antiderivative of e to the power of x? What's the number in front of x? Well, there's nothing. That means it's invisible 1. So according to the formula, the number in this problem is 1. And so the formula says put 1 over that number and then e to the same number again with the letter x next to it, plus c. By the way, all these ones don't have to be written down, so you could just write down e to the x plus c and you would be just fine. So it matters if the number is not 1, but when it's a 1, the number really doesn't have to be written down. And then finally, the 1 over x dx, the antiderivative is going to be ln of absolute value of x plus c. That one, is not up to debate. There's nothing you could do. It's just always going to be like that.